Hello students! So today we are going to talk about Geology. Lab 6 is Metamorphic Rocks. So this lab ends our journey through the various types of rocks. We have gone from igneous to sedimentary, and now we are at metamorphic. And this one I expect to be probably one of the shortest. And so when we talk about metamorphic rocks, over in page 61 in your lab manual, by the way, we talk about metamorphic rocks. There are two things that you need to drill into your head when you talk about metamorphic rocks. Heat and pressure. Heat and pressure. Again, heat and pressure. Wait, did I say it? Heat and pressure. Hold on, one more time. Heat and pressure. That's what you need to know. That is the two ways that metamorphic rocks are formed. Through heat and pressure. I'm going to say this a lot because this is the most important part. All right. So, the formation of metamorphic rocks through, surprise, heat and pressure, is a way that rocks are fundamentally altered to create an entirely new rock. So we know with igneous rocks we talk about weathering. When an igneous rock is weathered, and it's not just igneous rock, when a rock in general is weathered, both mechanically and chemically, it turns into a new rock. But when you apply heat and pressure, you can take a rock and turn it into another form of itself. So we have to talk about parent rock, right? So I have shown you one rock in particular. I believe that I have, I think my most popular one that I like to break, it's called phyllite. It's called phyllite, right? And phyllite is one that I've used as an example of a rock that cleaves. You know, we talked about cleavage and fracture when we talked about mineral identification. But phyllite is a sedimentary rock, but it also, through pressure, metamorphoses into a rock. This very shiny one, I will have samples for these in the later part of this video. This very shiny, scaly rock called mica schist. And that is done through pressure applied to the rock. That is, the rock is pressed so hard, the parent material is pressed so hard that it changes the rock. It turns it into something different. And so that phyllite, that sedimentary phyllite, is changed through pressure into mica schist. So, turn to page 62 on your lab manual. And so when we discuss heat and pressure, okay, we see various rocks that will give us a very clear picture of what they are because of this. So here's where we get into the metamorphic grade. So that is on page 63, I believe, is about rocks that are changed with temperature and how temperature changes those. And you might be asking yourself, well, at what area or what stage of a rock's life can it be changed with this heat, with this application of heat or this pressure? And remember that some rocks find their way back down into the earth, and the farther down you go, the more pressure is exerted, okay? Or over time, you will have sediment that will build up over layers upon layers upon layers. It will stratify and it will apply weight to the lower layers, therefore giving a large amount of pressure. Okay? All right. So, heat and pressure. Parent rock is metamorphosed into something new. And on 63, you have the metamorphic grade, which is a chart a lot like the igneous rock chart that you saw before that lab, and that I'm also using for the extra credit assignment here. Okay, but how do you tell the difference between a rock that is changed through pressure and heat? Well, this is fairly easy. You see whether it is foliated. You see whether it is foliated or non-foliated. Okay, so we talk about foliations. If you want to follow along here, we are on page 62. And it talks about how foliated rocks have been reoriented through pressure. There's an example in here about how you can have a jar of pennies, right? You have a jar, I'm sure you might have a change jar at home, I have one for sure. But when the change is in the change drawer, or change jar, you have that they are oriented all over the place, right? You can see like change is like standing up, so that's in various angles. But when you pour that out onto a table, it all flattens. It all flattens, and that is because of gravity. That is because the force of gravity upon that plane, the plane of that penny, is forcing it downward. It would not be very common for you to dump out a jar of change, and they just all stand up. It doesn't work like that. So, you will find that some rocks are reoriented by pressure, okay? Whereas non-foliated rocks, I have this piece of quartz right here. This is metamorphosed through heat. I know you can't see this very well, but we will have a part at the end here. This is what happens when you take sandstone and apply a lot of heat to it. This is what happens when you do that. And basically what happens is the crystals kind of fuse together and make a very dense, very strong rock, and you get quartz. But you can tell because the rock does not have layers. You can tell it does not have layers. So, I'm going to look at a piece of slate later on, right? And slate is metamorphosed from shale. Now, I know we've talked about shale before in sedimentary rocks, and you know that it's got lots and lots and lots of layers, but when you apply a lot of pressure to that shale, you get this very dense-looking rock called slate. And you can see that there are foliations in it, and you will see lines running through the rock. That is how you will tell. Now, there are some that might not be so readily apparent. Mica schist is also metamorphosed through pressure, but when you look at it, you might not immediately see. But definitely try and get a good glimpse of like one of the profiles of the rock to see if there are foliations. That is something that in the lab you will have to do. Your lab on page 66, you will have to identify the parent rock, right? The parent rock, whether it has foliations, and it will ask you about the metamorphic grade. And what you do is when you're trying to figure that out, this is a bit like we did with sedimentary and igneous rocks, is you will go back and you will look at the listed samples, right? And I will number them. I will go through and explain these. And what you'll have to do is you'll have to go back to the chart on page 63. And you'll have to say where in the metamorphic grade that they are. Okay. And IDing the rock, again, you can do that. I want you to know that just like with sedimentary rocks, you do not have to identify the rock, but it would benefit you to do so, given that on the midterm I may ask you to do so. All right. There really wasn't much of a lecture here because, again, heat and pressure. Come on, heat and pressure. If you're at home, say it out loud, heat and pressure. You don't have to say it back to me, but heat and pressure. All right. And remember that we talk about parent rock that has been metamorphosed into something else. And you can see that on the metamorphic grade, and whether it has foliations or not. So, stand by, we are going to give you the rocks for the lab. Okay, so on the lab, you are going to have to identify 7 of these samples. So what I'm going to do is I'm going to take each one, and I'm going to hold it up to the camera so that you can get a decent view of it. And you will have to identify the parent rock, whether it has foliations, and its metamorphic grade. So be sure to look at that chart on page 63. So sample A. See right here. So look for any, whether it is foliated or not. Note the color and the grains. It's kind of a hint there, the grains. Okay. All right. And be sure when you're identifying these to look back through the last couple pages and read up on those rocks, and this will assist you. All right, so sample B I talked about in the lecture. Yep. It might be very difficult to see certain parts of this. Yep, okay. And notice that it's kind of scaly looking, very shiny. Okay. All right, so here, this is a nice sample here. Yeah. All right, so take a look at whether it has lines that show foliation or not. And take note of its color. This is actually very important. Do take note of its colors. Okay. Think back to the igneous lab on this one. All right. Okay. Here's another. This is very common. Something you might find in silicaga. Okay. And note the texture. All right. Okay. Note the grains. Yep. All right. Sample D. Sample E. Sample E, another one that I used in a lecture. So you see, might be difficult to notice that. Notice the color. The color is very important. All right. All right, sample E. Sample F, I'm going to give you a portion of this answer, as there was an error in the lecture itself. This is phyllite. This is phyllite. And phyllite is metamorphosed from another rock. So, yep. In the lab, I accidentally called it sedimentary, so wanted to make sure that we were clear. So it's phyllite. So look at it. Look at textures. Okay. And the last one. And the last one. All right. So this one, very dynamic rock. Very popular to use for a variety of things. We definitely talked about this parent material in the sedimentary lab. Okay, sample G. Sample G. Okay, so again, you will go through these samples and identify their parent material and whether they are foliated or unfoliated. That's all I have for you, so please turn this in. You can either take a picture of it and send it to my email, or let me know. Thank you.